It's my great pleasure to introduce Kostas Kryptos, or also known as Kostas Kryptos. And Kostas will talk about ZK for authentication today. Take it away.
Yeah, thanks, Philip. So very quickly, this is work that we're doing for Mr. Labs and the Sui blockchain. However, I'm working on this topic since I started on blockchain like 7, 8 years ago with one of the first developers of Satoshi, actually Mike Harn. Then we couldn't find a solution on the first company that I was, like R3 for Corda. Not at Facebook as well. I used to lead the Libra protocol for, well, we never launched there. And now eventually I managed to launch a blockchain, which is like Sui. And however, whatever you will see here is typically applicable to any blockchain in practice, and some of the technology can actually be reusable. So I literally asked ChatGPT today to give me like an answer on the question why most of the people, apart from the degens, cannot join the blockchain world. And you see the first two answers were related to UX. In practice, too many jargon, like words, cryptography, zero-knowledge proofs, MPC, threshold wallets, secret sharing, and all of this stuff. And then the second one is obviously the experience when you're getting into a wallet. You're pretty much receiving something like that. And as you can imagine, the average Instagram user, I'm coming from Facebook, so I know how demographics work. It's very difficult to remember all of these things. And the other problem is it's not like a regular password. Maybe people can remember short passwords, but here for cryptography, we need something more with more entropy. I did some actually survey. Some people don't even know the words. I mean, if they are not native speakers, some of the words like, I don't know, saddle, stumble, garment, and some others, they don't know what it means. And in practice, when they have to use it, it's unfamiliar to them. And there are many situations where the words are very similar. Imagine the 3 yellow things there. And it's also another thing that it's like orthography. People don't know how to write them down. And in practice, we wanted to solve all of these problems. And we said, OK, today, MetaMask and all of the most popular wallets are going into this direction of requiring the mnemonics. Can we do something else? And actually, the whole question here is, can we not change the way people are authenticating either in a website for Web 2 or now in the blockchain? They don't even know that they have a blockchain account. And this is exactly, I mean, typically you might say, oh, this might be difficult. How do you connect Google and Facebook and all of the other companies with like blockchain? Because if you don't have a key, then, oh, is Google a custodian? And then you will see how together we're going to unfold all of the situation and how zero-knowledge proofs can help here. And eventually, you don't even require to remember any passwords, any keys, nothing, and still Google not to be a custodian. So accessibility I mentioned here, and you will probably have seen a product that was advertised recently in the news, like ZK login, and everyone is saying, oh, if you manage to solve this problem, you're actually solving the onboarding problem. But onboarding is not like the full story. In practice, for the first time, you might even have discoverable addresses. The same thing as PayPal and Venmo, and sometimes even Revolut. I type my email, and I know how to send money to someone. And this will change, obviously, the world of people who are not familiar with like all of these hexadecimal addresses and the QR codes for actually sending money to a very long string. And if we can manage to solve this together, like killing two birds with one stone, where they sign in with Google, then it will be like awesome and great. So in practice, we got whatever people are used to. We added extra privacy because this is required. And with your user ID, you're creating an account on chain. This is enough. You will be surprised now because you say, OK, user ID, Google knows my user ID. Can Google or Facebook actually impersonate me? And you will see that with the magic of zero-knowledge proofs and a few tricks, they cannot. Now let's go to the architecture. There will be some math here, but I will try to keep it simple. But in practice, if you understand the whole logic behind it, how we combined OAuth 2, OpenID providers with zero-knowledge proofs, eventually you can implement it either on like Sui, or you can even think about applications elsewhere. So what is happening when you're signing in with Google? In practice, in the background, you don't see it, but you're receiving these things. This is a JSON format, like a response from Google, that successfully, you are a user. The username is actually the flag with sub, the field called sub. I have striked out some of the elements there because it's one of our subs, and someone don't want to be non-anonymized. But Google is signing with some key that is in the top, all of these things that is in the bottom. And in practice, you can add more information here. For example, if you go to Facebook, you will probably see your photo, you will probably see your avatar, you might see also your full name, your email if you want, and everything. So Google gets all of this information from the permissions that you requested. It creates this JSON structure, we call it JWT, and it signs it with a key that is in the JWK, like the top one, like there is an identifier for the key. As you can imagine, with this, we cannot go to the blockchain, right? There is nothing that can help you to sign transactions. So even if we had a way to use like the signature that we get from Google to go to the blockchain, it's not easily like understandable how you can do it. And there, we added many tricks that I don't know why nobody tried them in the past, but we had someone who participated in the ceremony we had very recently in Go16. It's one of the most popular cryptographers in the world, actually. How the heck we didn't think about it all of these years? And I guess it's because zero knowledge proofs were not at the stage where they are now, like regarding the efficiency. And the second one, there is a very special trick here that without this, you couldn't do it, which is unrelated to ZK, but we use it very efficiently. So the first trick. Before we go to SNARKs, we realize that some providers are having this value in their JWT. There is a nonce here. And the nonce is typically provided by the user to avoid replay attacks. I don't want to get the same JWT again and again. And in practice, Google is asking you, like when you're doing login with Google, the UX, like the browser, is sending a random value to the request, and this random value goes there to the nonce. And then we said, oh, if we can have the user actually injecting something into the JWT, can we have the wallet creating a public key, fresh public key, random public key, and put the public key inside the JWT? And that's the first trick, because the public key is also random. In practice, you are replicating a nonce. If the public key is always different, you have a new random value. And there you can also add more things. It's not only the public key. You can even add personal custom expiration. You can even add rules. In any case, nonce is like metadata that the user wallet can actually provide to something that Google will sign. And then eventually, what do we have from Google? We have a digital certificate over anything that we requested from them to do. But the digital certificate, it's not only the data that we put inside, because everyone can put like some random value. It's linking this, because this is a structure signed by Google, with your username, with your email. And now we managed to get a certificate over our personal identifier, along with a public key that we defined. And now, oh, there is a public key now. Maybe we can use it for a blockchain transaction. Let's see. So the second trick is, how do you use this? Let's assume that you managed to put a public key there. How do you use this for blockchains? You have to define some address type where the long-term public key is not there anymore, because there is no long-term public key. And typically, if you go to the Bitcoin, it's typically your hash of your public key. But now there is no long-term public key. We had to find a way to put the identity now as part of the address derivation. And then let's see how we're going to use the ephemeral key that we injected inside JWT. And here, we start with some solution that didn't work. For example, a strawman solution would be, let's have a hash, your address being the hash of the provider, like Google, your wallet ID, let's assume MetaMask, and the user ID, which is like kostas@mistanlabs.com. And this, however, might have some issues, because there is nothing randomizing my address there, right? And I have a privacy issue. Everyone can see my user ID just by enlisting all of the providers, all of the wallet IDs, and all of the emails. And someone can figure out, oh, I'm losing my anonymity now. Someone can figure out that my address is this particular on Bitcoin, on Sui, on Ethereum, or wherever. So we have to think of something else. And then we said, OK, let's add some randomizer here. And we added the salt. And someone says, OK, the salt now is protecting you against someone identifying your address and linking it with your real identity. But there is a question, right? Who is keeping the salt? Because we said no passwords previously. You cannot have the user having the salt. And the solution is Although we say this is not safe, and I will explain why, let's use the wallet. Because the wallet cannot impersonate you. The wallet cannot sign on behalf of you on Google because it needs the credentials of you. But it's fine to keep the salt. Because just with the salt, it doesn't make it a custodian. It's just an extra value. And every time you go to your wallet, it will provide you the salt. And then with this salt plus your Google, you can go and create a transaction on the blockchain. The actual solution, however, is this one. And this actually helps us to even hide more things from the JWT. And we're doing a bit more complicated derivation of the address. And here we're using zero-knowledge proof-friendly hashes. So in SUI at the moment for ZK login, we're using this type of addressing. So it's the provider ID Google. Then we have a ZK hash of the wallet ID, the user ID, and again another ZK hash of the salt. And you will see later on why this is super useful, because we're not solving only the onboarding problem here. We will help on discoverability as well. So having this in mind, you can already, people who are cryptographers or can even understand that the hash is a one-way function, how someone now, by seeing an address on chain, they cannot identify my identity because there is some randomness here. And at the same time, they cannot even see my wallet because there is a hash. And anything inside the ZK hash is not sent publicly. That we hide it with zero knowledge. Just for your understanding, the JWT format defines AUD, which is in practice for us a wallet. And the sub is the user ID of the user. And we can also have email, someone using the email as identifier, and you can pick whatever you want here. We don't specifically say that the sub is the identifier someone will use. There might be social applications, for example, I don't know, Zynga Poker and others, that they will say, oh, I want to identify a user with privacy, but now with their Facebook account. And now we're going to the fifth trick. Now that we have a zero-knowledge proof address, we can get the JWT as a private input to the zero-knowledge proof circuit. And we say, OK, let's create a ZKP that verifies the correctness of the JWT itself, that it has all of the fields that you want. It also verifies the OpenID provider's public key and the signature in practice, because we said that this is signed by Google. But when we talked to all of these OpenID providers, they said, OK, even myself, I don't want to track people on chain. So because I know what signature I put on the JWT, and I know the JWT, please hide the JWT from the chain, and also hide my signature on chain. And then we put the signature inside the verification function of the circuit, and we verify RSA inside the zero-knowledge proof. And then the other thing that we check is, oh, there will be a fresh public key. This fresh public key every single time will be different. Let's also verify that the public key that we sign transactions with is inside the nonce of the JWT. And finally, that I know the salt, right? I know the pre-image of the address, because this is very important. Every single time I'm going to take over the address and be able to sign, I need the zero-knowledge proof that I know everything inside the address. And all of these are actually defining the system that like the ZK login is using, all of the ZK for authentication. And as you can see, it's like a combination of tricks. You couldn't do this without having a particular address style. You couldn't do it without hiding everything from the JWT. And you couldn't do it even with the requests that sometimes are very strict from the OpenID providers that I don't want to track my users, because I might have an administrator who is a rogue administrator, and they can do some identification attacks. So we put all of this into like one slide and how it works. Typically, you are getting the JWT by signing in with Google. You are putting an ephemeral public key inside the JWT. Google returns this back. You're adding a salt and the ephemeral key. You sign the transaction. And now the verifiers, compared to previously on the blockchains that they only do signature verification, now it's an ephemeral signature verification. You have to convince the validators that you also have a proof that you were the owner of this address. So as you can imagine, like verification now requires an extra ZKP, but there is a benefit here. This can be parallelized. Every user, and this is stateless, I'm just going into, I don't know, Bitcoin or SUI, and then I say, okay, I'm signing something, and this signature verification and the proof can be verified on parallel without requiring anything from the state. It's just a verification against some address, right? You don't need to know the balance of the address or the object that this address wants. So in theory, you can have validators that can verify all of these things in parallel. And that's why fast zero-knowledge proofs and parallelization make this possible today that it wasn't 3-4 years ago. So the whole story is, I don't know if like the font is big enough, but you take an OpenID login, you're adding zero knowledge, you're generating an address now linked to the identity, there is no public key internally, and then just by this you can view and manage assets. I have an example on how it works in practice, but yeah, that's the full flow. The user is like the app front, like the user below, the app front end is the wallet, but as you can see, the user doesn't see anything happening. Just log in with Google. Now, okay, we said there is a JWT format, but is everyone supporting it? That was like a big exercise, and we went to everyone, like Facebook, Apple, Google, Microsoft. Do you support nonces? Because not everyone is supporting nonces. And then we said, okay, let's take one by one, try to get the JWT, use the ZK login algorithm, and see if we can actually embed, inject the public key internally, because this one will make it compatible. And we realized that at least the top 5, Google, Facebook, Twitch, Slack, and Apple are compatible with this approach. For the others, we're still reviewing the situation, and if the nonce is not there, we're probably going to discuss with them. If you want like your identities to go on chain, imagine you are Xbox and you are Microsoft, and you want to use this system, please do according to the specifications of ZK login. Because in practice, this can also be used outside the blockchain. We don't know how this technology, because it's a primitive, and I will explain later why it's super useful, we don't know exactly how this will be used in practice, because it's not tied to a particular wallet. Everyone can go and implement this now. It's not like it's a MetaMask like IP. Whoever wants to implement this, it's open at native like functionality, not in a smart contract. And now you're a wallet provider, you want to have zero knowledge proofs on your wallet, advertise you have a wallet, you can go and raise money, you can do something better, like faster provers, faster verifiers, and you can have a business. So now some cryptography stuff. Let's see how far are we. Okay, I have 5 minutes, I'm good. So many things here, right? How can you make this implementable in something that in 1 second you can have a proof? You have to keep the circuit as small as possible. And here we managed to say that 1 million constraints with some like good provers, it can actually happen in 1.5 seconds. And this is okay. This is like pretty much what Visa and MasterCard are doing when you're paying with your credit card. There is another benefit that I will explain later. At the session, by the way, I can give you a hint. At the session of your wallet, you don't need to implement for every transaction zero knowledge proof. Because imagine you open your wallet, you define the fresh public key, you get this zero knowledge proof over this public key by injecting the public key into the like the cookie that Google is giving you, and then you can reuse it. You can sign many transactions with the same public key. As long as you remember this public key, you can reuse the same zero knowledge proof. If you change it, if you close the wallet and you go back again, you have to again log in with Google, get a new zero knowledge proof, and do it. But most people, especially if you are playing a game, imagine you're playing chess, and every move goes on chain, you're having your wallet open, right? So 1 zero knowledge proof, and then you reuse it. But anyway, even for the one, we wanted to keep it like small, and then the most operations are actually occupied by the SAT-256, the RSA signature verification, and some other like Poseidon hashing, base64, because unfortunately, Google is signing the base64 format of the JWT, not the bytes of the JWT, and you had to stick with that. For RSA, you cannot just use the RSA verification. You have to do some optimizations here. We did a small trick, like inspired by the libraries that you see at the bottom. Instead of like computing the R equals A times B mod P, we use the one in the middle. We actually do check an equation between two particular values, and this is actually faster. We have audits on this. It's already used, but without these optimizations, it wouldn't be possible to happen in 1.5 seconds. And then the same thing for base64. Base64 is it takes like 10% of our constraints. This is what you have to pay, unfortunately, because this is what ZWT is, this is how the standard works, but we have to make some optimizations here. In this situation, we have some like small downside that you can see at the bottom. To make the JSON parsing as fast as possible, we're assuming that the JWT provider is having like correct OpenID outputs, like the JWTs, and we're not handling in practice the nested JSON values. This is the only requirement that we have, but we haven't found any OpenID provider who is not conforming to the standards. So this is typically okay. And the final one, which was the most surprising one, you have to do some lookups inside the JWT, right? You're getting something, and then you say, oh, find the user ID to check if it's a pre-image of your address, and find the wallet ID internally to check again the same thing. You need slicing over strings. You need something to parse the string and eventually take some values from there, and then you're using these values to all of the constraint calculations. And this is very important to do it properly, because asymptotically, you know that the naive implementation would be n times m constraints, because imagine I have to split the JWT and then eventually look in all of the elements. If I find, for example, AUD, that we said it's the wallet ID, or I find my email, which is my email, and so on. And then we realize we can do something better. And this is the one here, like the third from the bottom, that as you can see, asymptotically, it's not better than the n times m. And this is where there's a difference between what Mr. Labs is doing and what Facebook was doing. So in Facebook, we had like a situation where most cryptographers are thinking about the future, like even asymptotically bring something better to the community. But in real situation, we're talking about a case of 1 million gates. And if you are using our optimization, you can go from 160K constraints to 33K constraints. So even if asymptotically this optimization doesn't make sense, you know in practice, when you are having cryptographers in your team, sometimes you have to think of the real parameters, and if some algorithm can work here better, even if the asymptotic complexity is the same. And here it's a huge gain, right? Because imagine we have to search for 4 or 5 fields there. We said the whole number of gates is about 1 million, and we already, if we didn't do like the optimized approach, we would, I mean, just with 5 lookups, we would cover like more than half of the constraints just using slicing on strings. And now we manage with 33K to actually have these 5 without occupying all of the gates in the system. That's why sometimes when we have generic VMs, in my opinion, it's good, and probably you can go to the next level, to the next step. We had Bobbin before, like talking about Maiden VM on Polygon and all of this stuff. But there are situations where you have to handcraft your smart contract and actually the circuit itself. If you're doing generic VM instructions, you might not be able, for the particular problem you're solving, to get the efficiency that you want. And here we had to do handcraft circuits. Now, optimizations. We did many more things, right? Even on verification. This is running on 100 plus validators. What do you do here, right? You need the pairing operations, the one at the bottom, to be run as fast as possible. So you had to do some pre-computations. And in this case, we prepared the verifying key. You don't need to know about this stuff, but this is an optimization. But because verification is stateless, as we explained before, you can do it on parallel. In practice, many blockchains can have validators that are multi-server validators. The signature, even on Bitcoin and Ethereum, even personally, I don't see why it's happening on the same server. You just verify a signature. Same thing as Web2, as Facebook and Google are public now and they can support so many users. Signature verification should happen on offloaders. The validator is receiving messages, you're doing signature verification very quickly, and then you move all of the messages to the actual core of the consensus, because signatures are stateless. And the same thing now with zero-knowledge proofs, and this gives us the ability to use zero-knowledge proofs in a situation where the server wants to parallelize, and they can do unlimited users in practice. The same thing, now do you know Google and Facebook, how they work, right? You have the database, and before the database, you have 100 offloaders. You're receiving all of the SSL connections. They can do the SSL decoding, and after that, no encryption anymore. you can do this on the blockchain when you can deal with stateless information, something that doesn't have to do with the transaction data itself and the state. And signatures, it's just you're giving an address, a public key, and the signatures, and you verify it without having a state. So everything is parallelizable here. And that's why we can manage to do all of these tricks. And plus the LRU cast trick that I mentioned before is because, as I said, whenever you are sending a zero-knowledge proof along with your transaction, you don't need to verify the proof again and again. It's reusable if you didn't close your wallet. And this is super useful to understand that even if you have like back-end provers, like every wallet will use it once per day or once per hour or once per 2 hours. It's not going to use it for every transaction it's doing, which is super cool. Otherwise, it would be super expensive. And here is how it works. In practice, imagine logging in with Google. Very quickly, you're going to your account. Voila, you have an account. Nothing else. And then you can send money, a transaction, and as you can see, there is no password anywhere in the process. So in the background, all of the things that we explained before happened, and imagine what this means for the game industry. Especially when we don't want people to change the way they're authenticating. And there are some big benefits here. Let me go. The video is a bit tricky. And the main benefits here are these things. And as you will realize, it's a native authenticator and chip, but there are many cool stuff you can do, especially in the middle, discoverable addresses. Now, with your email, because if you know who someone's email is, you can just send them a salt, and then they can receive money automatically. You can even have a zero salt. For example, if it's pay at Amazon.com, they don't care about the salt. People just type pay at Amazon.com and they send a transaction directly. They don't need to remember any addresses. And it's also claimable. You can send money to someone who doesn't have an account. Just go, I send you some money, just go sign in with Google, and you will have access to the account, which is super great, right? I mean, doesn't exist now on the blockchain. And the final thing is you can combine it with 2FA, like either log in with Google, or log in with Facebook, or log in with Google and log in with mnemonic, and also geofencing. Because now you can have zero-knowledge proof hashes, and this is the trick I told you before. You can now do the situation where with an extra zero-knowledge proof, you are proving that I'm someone with a .com domain, or a .co.uk domain, or .it domain, or .br domain. And this changes completely how addresses, like imagine gambling companies want to enforce some geofencing, all of this work. That's all.
Thanks a lot. All right, any questions? Yeah, I saw you had.
Thanks. Hey, so quick question, just to make sure I got it, because I did get a little bit lost. The cross-session persistence of the blockchain history, of the history for an address, is achieved through the zero-knowledge proofs? Or like, how do you access, let's say that I log out, I log in, carry out a transaction, log out, and then log back in and access that?
It's all based on how the address is generated. As you can imagine, the address is just a hash of your identity. If you can prove that you have a valid JWT with some public key that goes to whatever address someone is providing, you are good to access this address, and with the ephemeral public key signing transactions. And this is static, right? It's not ephemeral address. There is nothing here that is ephemeral. The salt, as we said, it's a static salt. User ID, obviously, is a static user ID. Wallet ID, static, and provider is Google, right? There is nothing that changes your address. So when the next time you go to your wallet, let's assume you were offline for 1 day, then you go to your wallet, you say to your wallet, okay, wallet, give me your salt, I will do a Google login, and I will provide to the blockchain a zero-knowledge proof that I'm the owner of this address, and this is the key that you're expecting now for the next transactions to sign. So the history is maintained because the address itself is permanent. If it wasn't permanent, this wouldn't work.
Okay, so the entire system depends on the integrity of the salt, right?
That the salt is fixed.
Yes, so if that salt gets compromised, you're...
If it's compromised, someone needs also to compromise the Google, Otherwise, I mean, just the salt is not enough to, it's a 2FA by itself, right? Okay. You need this, but you also need to log in with Google.
All right, further questions?
I just have a naive question: that how to verify that your login scheme is really zero knowledge and anonymous. Well, which means that if I try to to log in to Google, how to test that from the outbound traffic, the outgoing traffic or incoming traffic, to trace the packages, the packages or other ways to verify if you're...
Okay, so by the way, the JWT, we never send it. The signature from Google, we never send it because we typically send the zero knowledge proof and the fresh public key.
Oh.
You can see that the zero knowledge proof and the fresh public key go to the same address, as you can see with every other address on chain that this public key is for a particular address. But nobody is learning about this data, right? Because you never send these things.
Oh,
you don't even send JWT itself. I mean, the JSON that I showed you before, it's a private input, never goes online, never goes on chain.
Oh, yeah,
so in practice, this is how you maintain your anonymity here.
Oh, so as I can understand, there must be intermediate to send the key, to verify the zero knowledge proof.
No, the zero knowledge proof is verified by the validators.
Validators?
Yes, but the JWT is a private input to the zero knowledge proof. It's not a public input.
Oh.
So only the user provides this, and then the validators verify it.
Okay, I got it.
So yeah, I think we need to take the next questions on offline.
Yes, let's take the next offline. I will be here.
Kostas is still around all day, so please
Thank you,
find him
Philip.
during the break. And then, yeah, let's thank Kostas again.